Length. This is a fundamental dimension that defines the extent of an object or space along a straight line. It is the measurement of the distance between 2 points in one direction. In mathematics, length is typically represented by the letter L and is considered one-dimensional. This means specifying a point along a line only requires a single coordinate. Length is important in geometry, calculus, and physics, where it serves as the basis for defining other dimensions and quantities, such as area and volume. It is like being stuck on a never-ending single-lane highway. No matter how far you travel, the road stretches endlessly in front of you, mirroring your past journey behind. You can only go forward or reverse with no escape routes or detours. Hit a bump in the road, you're stuck going over it, or tediously backing up until you find a smoother path. This limited movement reflects the concept of a one-dimensional world. While vast in its own way, it offers no freedom to veer off course or explore anything beyond the confines of that single line. Width. This is measuring distance across an object or space perpendicular to its length. It represents the extent of an object in a direction orthogonal to its length. In mathematical terms, width is often denoted by the letter W and is considered one-dimensional. Like length, width requires only a single coordinate to specify a point. In practical terms, width is essential for describing two-dimensional objects' size and shape, such as squares, rectangles, and circles. Depth. This is measuring distance into or out of a three-dimensional object or space. It represents the third dimension in addition to length and width, providing an object with a sense of volume or thickness. In mathematical notation, depth is typically represented by the letter D, and is one-dimensional like the other spatial dimensions. Like length, width, and height, depth requires only a single coordinate to specify a point within it. Depth is essential in describing a spatial relationships of objects in three-dimensional space, and is crucial in fields such as architecture, design, and computer graphics. Time. Our brains are weird to perceive time linearly. The past is a fading memory, the present a fleeting moment, and the future an unknown horizon. But a fascinating paradox emerges when we go into the realm of dimensions. Here, time sheds its familiar guise and becomes something altogether different. If we could perceive time like we do the three spatial dimensions, we wouldn't see a world unfolding moment by moment. Instead, we'd witness a breathtaking spectacle. Every person and object frozen at every point in their existence, all at once. Each individual would resemble a long, twisting, three-dimensional time snake, thin at its origin, symbolizing birth. This form would grow and thicken as it accumulates experiences. Then it would inevitably taper off towards its end, representing decay and dissolution. Probability. Probability is vital in this dimension because it determines the likelihood of specific outcomes occurring. In a universe where events are determined by probability, the likelihood of any specific outcome can be calculated based on factors such as initial conditions, laws of physics, and random chance. This dimension suggests that our universe has countless variations, each with unique circumstances and outcomes. Probability helps us understand the likelihood of these outcomes occurring within each universe and allows us to explore the vast possibilities beyond our reality. All possible universes. Imagine a flat world with left-right and up-down, our familiar two dimensions. Add height for the third, allowing movement through physical space. But introducing time as a fourth dimension bends the mind. Time stretches endlessly like a line into eternity. Now stack these timelines, forming a vast sheet of possibilities. The fifth dimension. Enter the sixth dimension, where time becomes a cube constructed from these timelines. Here you leap through space and time, effectively teleporting across timelines. It's as if you vanish from our universe and reappear in another. A mind-boggling concept. This is the multiverse. Every outcome from the Big Bang branches into its own universe. In this realm, you could find worlds with dinosaurs, different physics, or even magic. The sixth dimension offers exploration into these diverse universes, beyond imagination's reach. All possible spectrums. Imagine our universe as just one thread woven among many possibilities. Like a spectrum where various forces can be adjusted, picture a line on paper representing universes where only gravity is tweaked. Our universe sits at a specific point on this line. Moving along weakens gravity in every encountered universe. Each point represents a slightly different universe with weaker gravity. However, The 7th dimension limits adjustments to one law at a time, hindering exploration of universes with variations in multiple laws. To address this, we need a 2-dimensional plane to explore combinations of laws. Adding an 8th dimension allows simultaneous manipulation of 2 laws, while the 7th dimension offers insights into diverse universes. It's constrained to changing one law at a time. Higher dimensions might hold the key to exploring even more varied universes, a concept pushing the limits of our understanding. Plane of possible universes. In the realm of theoretical physics and cosmology, there's a concept called the multiverse, a vast plane where every imaginable universe exists, each with its own laws and conditions. This idea suggests that variations in fundamental parameters give rise to different universes, leading to diverse cosmic structures and even life forms. For instance, while our universe has finely tuned constants like the speed of light and gravity, in a multiverse, these could vary, resulting in entirely different realities. The multiverse theory emerges from attempts to explain phenomena like fine-tuning in our universe's constants and quantum mechanics. Though speculative, it offers a framework to explore existence beyond what we observe. Direct movement. Forget what you know about dimensions. The 9th dimension is a gateway to an entirely new multiverse, where reality becomes a playground of unimaginable possibilities. In this realm, you could vanish from one universe and reappear in another, experiencing worlds with different laws of physics and fundamental principles. From twilight universes to realities where the very concept of life takes on new meanings, the 9th dimension offers access to infinite variations of existence. However, comprehending this dimension surpasses our current understanding, rooted in theories like string theory. While reaching it may be beyond our grasp, its existence challenges the limits of what we thought possible. Infinite possibilities. The concept of the point of everything takes on a whole new meaning when considering the 10th dimension. Here, the entire pattern we observe throughout the dimensional journey culminates in a mind-blowing singularity. Now at the 10th dimension, we reach the peak. We've condensed the 9th dimension, which supposedly encompasses every conceivable possibility. Every universe, every twist of fate, every variation in physical laws, into a single solitary point. This point in the 10th dimension embodies the point of everything. It's not a purpose or a grand design, but rather the absolute totality of existence. Every event, story, and universe that could or will exist is compressed into this singular point. The 10th dimension takes this concept a further step. It suggests that any story you can conceive, no matter how fantastical, has likely played out in some corner of the infinite multiverse. Star Wars, Lord of the Rings, and even the most outlandish fictional universes all potentially have a basis in reality somewhere. After all, in an infinite expanse, even the most improbable scenarios have a non-zero chance of occurring. The 10th dimension signifies the ultimate limit. It's a concept that pushes the boundaries of human comprehension and forces us to confront the vastness and potential strangeness of the cosmos. We may never truly grasp the full implications of the 10th dimension. Still, the idea of its existence broadens our perspective and inspires awe for the mysteries beyond our current understanding.